So you guys ready for some exciting equation solving experience? Say no, then this is why we're going to try to get you ready so you can appreciate how exciting the experience will be. Because if you do it now, then you'll enjoy the test. If you don't, then you'll suffer in the test. If you're already ready, you already start to appreciate the unit circle, the infinite possible solutions. I'll be happy, if you can do that now, right? Anyway. Oh. Just real quick. All right. So just to quickly recap, for a very typical process of solving trig equations. So basically, your goal is to isolate the x, right? Whenever you call solving for equations, but you couldn't quite do that since the function, like sine, cosine, tangent, right? They're in a way. So therefore, your goal is to first isolate those trig functions, right? So take the sine with it, right? So once you get to those more fundamental equations, by fundamental, I mean you have that single trig function isolated and is equal to a number. So now if you have a calculator, you could easily find out one solution, at least, but most likely, in some ugly numbers. But with the unit circle, you will find most likely two solutions in a slightly nicer form. There are probably some good numbers. It's going to be special angles, right? 30, 120, 150, 300, or in radians, if you could, start to push yourself a little harder, right? To get used to using the radians. And if you're able to do that, by getting at least one, hopefully most likely two solutions, right? Whether it's in degrees or radians, you are 90% down for the problem. The last 10% goes to the way of writing the solution. That's why I'm saying that. Would you appreciate there are infinite many solutions out there? Most likely not, right? Since there's so many. But you're probably gonna like this, situation with the trig equation is that it doesn't really take you any extra effort to write down infinite many solutions, provided you know those two fundamental ones. Right? Or if you're like 60, 120, see that the little trick behind it is to just always add a multiple of 360, right? If you're dealing with degrees. But when I say add, it doesn't really have to be adding. You could subtract. Therefore, I'm going to put a structure of a solution in a form of whatever solution you got, right? As a fundamental solution, you're going to always put n times 360, where n is going to be 0, plus or minus 1, plus or minus 2, and so forth. And n will just be an integer. And hopefully you'll be able to transform, right, degrees into radians. So looking at pi over 3 or 2 pi over 3. But instead of adding the multiple of 360, you're going to have to add the corresponding radians, right, for 360, which is 2 pi. We're going to add a multiple of 2 pi, right? And could be, again, 0, plus or minus 1, and so forth. So say that, you just remember that. Don't forget to add this kind of multiple, right, of 2 pi or 360, then you're done, right? But what do you think will be, if I zoom out, I'm not, saying that you have to, be very good at, doing the whole process. But can you guys tell me, like, what will be the hardest part of the whole process? In your experience, because for me it's hard to say, right? Every students might be, or at least from the instructor's point of view, right? But I might want to also know from your end, what part of this might be the hardest? Okay, Anaya. So these parts, are they hard or easy? They're not as bad, right? But it's just that probably that the way or the reason why people might think this is hard is it's just awkward, right? It's because you're more used to having one or two solutions. That's it, right? When I say they're infinite many, that means you have to list them all, right? And figure out a way to list them all. Yeah, but I'm happy you say that they're not too bad, right? What else? Any part that bothers you the most? Find out those two fundamental solutions, right? Okay. And you know that using the unit circle is a very reliable way, which is not necessarily the way you like, but it's a very reliable way because I keep using it, right, to find out these two fundamental solutions. Okay. So again, I guess that it's either that you have to write your solution in this kind of formal way that might bother you, but just like Anaya said, they're hard to, accept, right? But not bad at all, right? If you just remember the pattern. But this is intellectually hard. If you want to make sure that you always get it right, right? I might not be able to get it right every time because I have to be careful with it. So let's see something like that, just to have, more exposure to those kind of, tricky part, right? And also you will see that every time we try to write the solution in such a form, maybe after, today's lesson, the last part of just writing the solution in this kind of funny way will never bother you anymore, okay? Now, let's move on to the next example. Let's take a look at, the tangent. And it turns out that tangent will have to be, worked out in a slightly different way. And therefore, they wanted to see the exceptions. All right, now first off, at least that we have the equation already in the fundamental form, right? So you have something like tangent theta, right? I don't care what 2x or x over 2 is. To me, it's just an angle, right? So tangent theta is radical 3. The question is, how would you find out such an angle theta? If you can get it, then it will be a lot easier to get x. Max? It's like that square, like, sorry, not square, the angle double. Never mind. Oh, I'm just saying that, let's say in what degrees that tangent of that angle will be radical 3. Would you guys to be able to remember that? 45 is 1. So tangent 45 is 1. Yeah, it's either 30 or 60. All right. So what I'm thinking is in a test, I could provide you a chart of those special angles, 30, 45, and 60, right? Sine, cosine, tangent, the chart that, you guys have to remember, but I don't mind to provide you that in a test. At least that, relieve, some of the pressure from you. But I do want everyone to see, however you do it at this point, using the calculator or look it up, right? It turns out that angle theta is 60 degrees. Okay, or you guys know in radians it will be pi over 3, right? Okay, good. I'm not looking for theta, right? I realized that 2x is what I mean by theta, right? This whole thing is an angle. Don't you think that 2x better be 60, right? Plus, not sorry, or pi over 3. Now, here's what most people are going to do, and that's why I'm showing you. If you do that in a test, you might lose points because you're not including all the possibilities. Just like the sine and cosine, right? How would you make sure that once you get a fundamental angle, would there be other possibilities? That means you're gonna have to think very hard. Could there be some other angle, which most likely not gonna be an acute angle, right? So that the tangent of it will be also radical 3. And it's hard to think about what it is. Therefore, I suggest that you remember something very special about tangent x. You guys know the period of tangent. Is it pi or 2 pi? Period of tangent. Pi. Even 2 pi is still the period of tangent, right? But pi is actually the smallest period. So now, here's a little trick, only works for tangent. So what you're going to do is, as soon as you get the fundamental angle, and what you're going to do is just go ahead and add n times 180 degrees. Just like you did with the sine and cosine, right? So you're going to add multiple of the period. But for a sine and cosine, you have 360, but for tangent, it's going to be 180. Or I'll add n pi, right, if it's in radians. So now you see that I'm including all the possible angles, right? So 2x could be 60 times n times 180, right? Or pi over 3 plus n pi. But what will be the corresponding x? That's what I'm looking for. How would you get x if 2x is given already? You would divide out the 2, right? That's exactly what you do, right? So it will be 60 plus n times 180 degree over 2, right? Or pi over 3 plus n pi, right, over 2. But, if you could, please do not write it like that. Simplify it, right? So say it's 30, right? Just split the fraction, plus n times 90 degree, right? Or this guy's going to be pi over 6, right? Plus n times pi over 2. Now, is that okay to write it just in a slightly prettier form? But, if you seriously want to leave it like that in the test, but I'll still give you credits. Right. But this is more conventional. Yes, Emily. Good question. So, what did we say about n in the previous problem when it comes to sine and cosine? N is a integer, right? And you're going to tell me either n is an integer, or if you like to make it fancier, so you're going to go 0 plus or minus 1 plus or minus 2 dot dot dot. Okay. Yeah. But we're not done yet, right? But let's say up to this point, anything that bothers you? Max?
That's it when it says more than or equal to or less.
Okay, that's something we have to, address. Good question. Now, anything else so far that has bothered you? Let's say if I were to just give you a chart, that you'd have to remember what angle, when you take the tangent of it, will be radical 3. You'll be given, right, those special angles. You figure x to be 60, right? So I think that you guys don't have any question, like converting to pi over 3, right? It's just that adding the multiple of pi or 180, right? So you probably didn't realize you could do that. So now, if you were to remember for tangent, you have to do that. And later on, it was you guys telling me that should divide out the 2, right, to get the actual x, right? That shouldn't be too hard. And recall that you should tell me that n is an integer. That's all. Yes, Alex. Okay. You know what? Maybe if that does bother you, I think that it's a very valid question. So let's take a look at what's going on with tangent graph. GeoGebra. All right, so let's plot tangent. Okay. So remember that my goal is to figure it out. That I could type in tangent data, but it doesn't make any difference, right? You're just plotting the function. So I want to know at what angles tangent will be radical 3, right? So let me type in a constant function. So radical 3, it doesn't do that, okay. Let me type in y equals radical 3. And you know what? I could even show you the scales. Now, if I could read off the first point of intersection, it turns out to be either 60-degree, right, or pi over 3. So that's the first angle that you can get either from my chart I'm going to provide you in the test, or you can just type in the calculator, right, do the tangent inverse of radical 3. Do you see that? This is not the first or not the only point where tangent will be reaching the same number, radical 3, right? It will be this guy, that guy, right? Or even here. But do you see how all the other points of intersection are related to the first one? I wish I can show you, better scales. But it turns out that since the tangent function is periodic, and the size of each, tangent graph is pi units. Therefore, if you go from that point to the same point on a different one to the right, you're adding pi to the location, right? You're going to keep adding pi or keep subtracting pi to get all those points. You see that if you know how the tangent behaves, if you have the graph in your head, right, you will notice that, you're not happy about pi over 6, 60-degree, right? You know that there will be infinite many possibilities. But all you have to do is track them by adding, subtracting multiple pi's, right? Or, 180-degree, right? I'm glad you raised that question because I think that maybe, almost every single student will be confused about, what's the rule behind it. Right now, anything else before I move on to the last part of the problem? I'm glad that Max raised the question, like, what are you going to do about x better be in that range of a 0 to 2 pi? Before I do that, any questions about the work so far? I believe that there, it's doable, right? Not necessarily, that you can get it right, on your own, but that's why, try to practice this kind of process for a few more times, right? You'll get it. So now the question is, I need to make sure that whatever x I'm getting needs to be in that range, right? So, I mean, if I tell you what you have to do, it sounds pretty, I don't know how to put it. It's just not as advanced or, mathematically, rigorous as you normally think, in a lot of the processes. Since n could be any integers, right? What if I start from n equal to 0? Since you have 0 to 2 pi, is it okay if I ask you to only think about the radians? So I want you to think about what could be the allowed value of n, so that when x taken a form of pi over 6 plus n times pi over 2, it will be greater than 0, greater than equal to 0, but less than 2 pi. Say, can n be 0? So x is going to be pi over 6, right? Is that in a range of a 0 to 2 pi? Yes, right? Check. So we need that one. What about equal to 1? So x is pi over 6 plus pi over 2, right? That is pi over 6 plus 3 pi over 6, which is 4 pi over 6 will be 2 pi over 3, right? Am I right? Okay, so we need it. It's still in a range of 0 to 2 pi, right? Check. And equal to 2. X is pi over 6 plus 2 times pi over 2, which is pi over 6 plus pi. It will be 7 pi over 6. Is that still in a range? Yes, unfortunately, it is still in a range, right? And equal to 4. Pi over 6 plus, oh, sorry, my bad, 3. Am I skipping a number? Yeah, go ahead. Wait, how many? I don't know. It depends on how many questions are there, of this kind. Yeah, but it's good that you're now thinking about how long do you get for a question like that. So you better be fast on some easy questions and save as much time as you can for those kind of questions. Okay. Yeah. Because that's why we're adding multiple pi's. All right, so 3 times pi over 2. So I guess that it will be pi over 6 plus 9 pi over 6, right? That'll be 10 pi over 6, which is 5 pi over 3, right? Would that still be in a range of 0 to 2 pi? Are you guys able to tell? Is 5 pi over 3 less than 2 pi? Yes, it is still less than 2 pi. Okay. So now, since this is, if you realize that 5 pi over 3 is so close to 2 pi, right? It's just less. There's no need to check the 4 anymore, right? It's gonna add, some big angle to it, right? So 4 is not gonna work out, right? Or if I put x equals pi over 6 plus 4 times pi over 2, it's gonna be greater than 2 pi. Okay. Now we're gonna get 4 solutions, but you guys realize that n could be negative. Should I try angle to -1, -2, -3? Why not?
That would put it out of range.
Right, because you realize, since x has to be greater than greater than or equal to 0, right? To make n to be negative, you realize right away, right? It's not going to work out, right? And it's going to make it worse when you get more and more negative n. Therefore, we have 4 solutions. All right. But like it or not, that's we end up dealing with the tangent, right? So the special part of the tangent is the period is different from the sine and cosine, and also if somehow you get the unknown, which is not as simple as x, you can have a multiple of x, right? You can have a fraction of x. You might end up getting those solutions that the best way to get them all is to just try different ends to make sure that it fits into the range. But also you have to make sure that you read the question to know that what kind of range they want it to be in. They might not always use 0 to 2 pi. They might say from 0 to 4 pi, right? Or 0 to pi, right? So you're gonna have to, but like I said, since there are, 10 things that you have to think at the same time, right? So I won't be that nitpicky. If you are getting most of the stuff done, then as long as I see that, you're on the right track, I'll be generous with the points. We know there's some deal breakers, right? If I don't see students showing me like how to figure out the fundamental angle, right? So that's a deal breaker, okay? Or people are not writing the solution in terms of n, right? That's again a deal breaker. Now, if you somehow getting only 2 of the angles, right, missing 2, you see that if I only have 5 points for a question like that, missing 2 answers, we have all the work in and front, that worked out almost perfectly, right? I might even think about, 4.5, right? 4.5 for, a problem that works 5 points, okay? Anyway, now let's take a look at cosine. You've seen the sine, right? The tangent, and now the cosine, but they're also adding some complication to equations involving the cosine in this case, because you might have to factor, okay? And it's actually quadratic. So let me ask you to recall what we did in our question, involving the sine function. Right? Remember I said that your ultimate goal is to try to isolate the x, but cosine is in a way, right? How would you be able to isolate the x or have to take a cosine with it? Can you guys figure it out how to isolate the cosine x, pretty much, from that equation? And this is what you should be thinking, right? What if it's 4 times x squared minus 3? How would you isolate the x? Well, I'm sure you can see that it's going to be 4x squared, right, equal to 3, right? Just adding the 3 on both sides. You're going to go divide both sides by 4. Square equal to 4/3. Oops. You conclude that x has to be plus or minus radical 3 over 2. Right? So that's what we know, right? Back then, maybe in 1.5 from college algebra. So now we have 4 cosine squared x minus 3 equal to 0, right? So we should do the same thing, right? I'll put dot, dot, dot. So I hope you see that cosine x is nothing but plus or minus radical 3 over 2. Right? You guys are okay with that? Just isolate the cosine x. And now we are actually getting 2 fundamental equations, right? So equation number 1, we have to solve cosine x equals radical 3 over 2, right? And another one is going to be negative, right? But pretty much if you see how to solve the first one, the second one will be a lot easier. Okay, so now, like I said, I'm going to provide you a chart with all the special angles, 30, 45, and 60, right? And then you have the cosine of 30 degree is radical 3 over 2, or pi over 6. But this time, like I said, try not to spoil yourself all the time with degrees. So how about we prepare ourselves, for the radians? So I claim that it will be pi over 6. Right? Let's just, it's nothing but 30 degree, right? But we want to write it in a fancy way. Would there be another possible angle? So that you take the cosine of it will be also radical 3 over 2. Please don't forget that cosine and sine are very similar. Pretty much that whatever you could do to the sine to find out multiple angles, we could do the same thing, right, with the cosine. Right. So what do we do to find out that second angle for that equation involving sine of x? What do we grab? The unit circle, yeah, right, the unit circle, okay? So let's take a look, all right? So the unit circle, all right, so a point, I'll say somewhere here, right? the angle is pi over 6. At that point P, right, is I like to use theta, but somehow they insist it has to be x cosine theta, right, sine theta. So since we're looking at a cosine, which is the horizontal coordinate, right, of the P, that means that we're looking at the projection of the P onto the x-axis, and the segment here should be radical 3 over 2. Is that right? All right, so again, the P is somewhere on the circle. The radius is going to be 1. And we figure, according to the unit circle definition, the way to track what the P is of course, by going with the xy coordinates. But since we already see that, just by definition, the angle, right, associated with the point P will tell us the horizontal coordinate, which is the x coordinate, has to be cosine of that angle, right? Now, if you go down, you see that this is the x coordinate, right? If that is what we have figured out, radical 3 over 2, that is, that segment has to be, fixed at this length. Okay, so basically, we're now looking at another angle different from pi over 6. And the point associated with the angle has to be on a unit circle in such a way that the second point will have the same exact horizontal coordinate as the P. So where do you think that second point has to be? In the fourth quadrant, right? So we just draw a vertical line and let it intersect the lower portion of the circle, right? You figure that, this is the point Q, right? And it has the same horizontal coordinate. That's why I'm putting cosine theta to remind you that it's the same as the P, right? Because you see that the horizontal projection of the location of the P and the Q are the same, right? Now the question is, what will be that angle associated with the Q? And I'll use a different color to label it. So you have to go all the way here, right? What do you think? 11 pi over 6, right? How did you get 11 pi over 6? Okay, so because you see that the angle as you go down, right, in the wrong direction will have to be symmetric, to that angle up there, right? If that small angle has to be also pi over 6, you are pi over 6 away from a full spin, right? That is 360 or 2 pi, but less pi over 6. That's a big angle, right, will be 2 pi minus pi over 6, which works out as 11 pi over 6, right? Therefore, we're getting the second possibility, 11 pi over 6, right? Now, how would you write the solution in terms of, yeah, go ahead, Max. Go ahead. 2 pi n minus pi over. Okay, you could do that. So yeah. Now you know what? Let's write it down. So, but first off, since we have an easy angle, can we just do pi over 6 plus 2n pi? Right. That's one of the options, right? And you said, can we do 2n pi minus pi over 6? Is that what you said? Do you guys think that this angle is equivalent to 11 pi over 6 plus 2n pi? Are they equivalent to each other? Or basically, do you think that negative pi over 6 is equivalent to 11 pi over 6? Are they coterminal? So if you go down in a negative direction, you're getting negative pi over 6, right? But if you decide to go all the way around, you're getting 11 pi over 6, right? That means this is absolutely fine. So if you like to have some kind of a symmetric, angle choices, because it's positive pi over 6 and negative pi over 6, do it, right? But later on, if you have to play with the angle to make sure that it fits into the range, you know that it will be a little bit different than, wherever you choose to go with 11 pi over 6, adding the 2n pi. But mathematically, they are equivalent, right? All right. Now, let's see. There's some restriction going on, right? How would you make sure that x is going to be in a range of 0 to 2 pi? And guess what? We do the same thing, right? You see that we can play with the n. And again, remind yourself that what is n? Integers. The possible number for n is 0, plus minus 1, plus minus 2, right? So you just go ahead and screen through, right, some possible n starting in front of 0. You will see that there will be two angles fitting to the range of 0 to 2 pi. And it turns out you can only take n to be 0 in this case. Otherwise, it's going to go beyond the range, right? So in order to make sure that x is in a range of 0 to 2 pi, the only two angles we're going to have to pick will be pi over 6 and 11 pi over 6. Okay. Now, in the choice of Max's choice of the second angle, so he has to take n to be 1 to get 11 pi over 6. Do you see that? If you ever go with 0, you get negative pi over 6. I mean, nothing wrong with it, but somehow they want the angle to be between 0 and 2 pi. Okay. But at the end of the day, the two angles from the general solution has to be in a range of 1. Yes. So to answer your question, let's say, how would I grade the work, right? So you know what to expect. Okay. Now let's say if I have 10 points for this question, because there are two equations, right? So 5 points for each equation. So I'm going to give 1 point for you figured out the fundamental equation, right? And I'll get 1 point for each fundamental angles. So now if you like 11 pi over 6, you're fine. If Max like negative pi over 6 for the second angle, that's fine, right? So both of you get 2 points. And now you see that if I only award for 5 points, I've given 3 points already. There are 2 points, right? So 1 point, I'll give to the general form, because I know that you're just adding 2n pi, right? If you already figured out two angles, you're just adding 2n pi to get 1 point for both forms, to show me that you realize there are infinite many solutions. You know the right way to write it. Now, at the end, I will award 1 point for you confirming that these are the two angles that fit in the range. You might say, Dr. Wang, why I have to tell you that? Because you see that those are two angles right there. But things are different. At that point, you're assuming that you're solving the equation in general. You find out what the fundamental solutions are, you're going to add the infinite, possibilities, right? So that's the routine things to do. But if you don't tell me this is your final answer, because you realize the range is from 0 to 2 pi, I'll assume that you haven't done yet. But let's say if I do see that, you're on the right track, right? If seriously, you're getting, I don't know, 89 out of 90, just missing that point, I'll go back and think about maybe just get you that point, right? Because, I mean, after all, you do get the right answer, right? That might be a happy coincidence, or that might be an honest mistake that you didn't confirm, right? But again, I'll see that if you do need that point, because again, like I said, since if that will be one of the force tests, hopefully that's going to be the one that won't affect your grade too much, right? So I don't think that, getting a point off or not, it's going to make that much difference. But it might make you feel more accomplished if you get 90 out of 100, right? So we'll see about that. But I'm sure that you're going to get multiple credits, right? But to show me how I grade your work, what I'm expecting, what will be the most important thing, you have to show me, okay? If you do have something missing, again, I'll try to be reasonable, right? Anyway, so now it's your turn to try to solve almost the same equation, but with the negative possibility. So what if I have the second equation? So let me erase those marks in case that people get confused at what they mean by ones, right? So I'm going to have you guys to try in the next maybe 10 minutes, or hopefully won't take that long. Okay, the second equation you have to solve for this problem, equation number 2, right, will be cosine x equals negative radical 3 over 2. Go ahead. All right. So I wish you would tell me at the end, there's still 2 angles. And if you're asking me, will that chart I'm providing you in a test include cosine of something equal to negative radical 3 over 2? The answer is no. That means you have to figure it out using the geometry, the root unit circle to figure it out. If you know how that cosine could be radical 3 over 2, what if it's negative radical 3 over 2? And please remember that cosine represents, geometrically, the horizontal coordinate of a point. Right? You have to come. All right, if you've got at least one angle or two, that'd be great. I would like to see. And seriously, it has something to do with that 30-degree angle, if you realize. Oh, yeah, actually, you're getting used to the radians now?
Yeah, I still don't like them. Is this for?
You're adding, you're adding half pi. See here, the period is going to be 2 pi. You're adding multiple 2 pi. So for sine and cosine, you're going to add 2n pi. If you're thinking about the previous problem, why am I adding? Now, look, this is one of the angles you want, right? Mm-hmm. But you want to make sure that you account for its all coterminal angles by turning around and around. Do say that to get all the coterminal angles, you're adding multiple of 2 pi, right? Yeah. So it will be n times 2 pi added to the angle. Now,
so it's like just as a general rule,
for sine and cosine, yes. Yeah. Mm-hmm. There you go.
But for tangent, you just have
the pi, yeah. Okay. Because sine and cosine has the period of 2 pi, right? But tangent has the period of pi. All right. So it's okay if you haven't, got both angles, or I think that it might be, pretty close to getting them. So I would like to show you, if you are now getting used to drawing the unit circle, take a look at the one I draw, see if it makes sense. Again, cosine x or cosine is the horizontal coordinate, right? So now instead of having the coordinate to be positive radical 3 over 2, it will be on the other side, right? Perfectly symmetric. But it will be negative radical 3 over 2. So the reason why I don't have to tell you, what that angle is, well, I'm sure you can see that if that small angle right there is 30 degrees, isn't the angle here 30 degrees as well, right? But I don't like the kind of angle because it didn't start from the positive x, right? So now you tell me how much that big angle is that goes all the way to the point P. If we are only 30 degrees away from 180, right? So isn't that 150, which is 180 minus 30, right? To get you 150. Or hopefully you guys now start to like the radians. It's pi minus pi over 6, right? Pi is 180. 30 is pi over 6. You get 5 pi over 6. Okay, so now what about the other angle that goes all the way to somewhere down below? But you realize, oh, now it's not, we're 30 degrees less than, 180. We're 30 degrees more than 180, right? So we're adding 30 to 180 or adding pi over 6 to the pi. So that bigger angle, so basically x is pi, 5 pi over 6 plus 2n pi, or 7 pi over 6, because we're adding pi over 6 to the pi, right? To add 2n pi, right? That's the fancy way to write, all possible solutions. But they are rooted at these two fundamental angles. And the way to find those two fundamental angles is, like it or not, the geometry using the unit circle. Yes? Would you have to? Yeah. You have to write both of them.